The question says which one of the following is an inner orbital complex as well as diamagnetic by nature. Okay, inner orbital complex is formed by strong field ligand. Any complex in which in general strong field ligand is there, in that case pairing of electron will be taking place. An inner orbital complex formation also takes place. Okay, inner orbital complex. Now you can see in all these complexes we have ammonia ligand. In general, if a ligand is starting from carbon and nitrogen is considered to be strong field ligand, pairing of electron will be there. Okay, then we can say in all these complexes strong field ligand is there. It is not so. Always keep in mind ammonia, obviously it is a strong field ligand, but it acts as a strong field ligand with certain metals only. It does not act as a strong field ligand with all the metals. Okay, for example, ammonia acts as a strong field ligand with cobalt, cadmium and copper and iron. Only these four metals are there. Okay, cobalt, cadmium, copper and iron. Only with these four metals ammonia acts as a strong field ligand. So now we can see, look at the option. You can see cobalt is there, here ammonia acting as a strong field ligand. Okay, chromium is there, it does not act as a strong field ligand. You can see nickel is there, ammonia does not act as a strong field ligand. Zinc is there, ammonia does not act as a strong field ligand. Okay, from here we got the answer. Okay, but anyway, if you want to justify, you can see in this complex pairing of electron will not be taking place. Okay, in these two complexes also pairing of electron will not be taking place. Only pairing of electron in this complex will be taking place because ammonia is acting as a strong field ligand. Okay, ammonia acting as a strong field ligand. Let's do it. To apply valence bond theory, anyway it is asking about the magnetic properties. Then we apply valence bond theory, and to apply valence bond theory we follow the step. What are the steps? First calculate the oxidation number of the central metal atom. Next we have electronic configuration of a central metal ion. Next we write orbital notation, and in orbital notation we have orbital notation, and in orbital notation filling of electron is done considering the effect of ligand, whether we have strong field ligand or weak field ligand. Strong field ligand pairing of electron, weak field ligands no pairing of electron. In this case we follow Hund's rule. Okay, first complex we have cobalt there, we calculate oxidation number. We have cobalt, it is ammonia, it is neutral ligand, unidentate neutral ligand is there, and our overall charge is what, plus 3 is there. Cobalt plus 6 multiplied by 0, overall charge is what, plus 3. From here we got cobalt is present in plus 3 oxidation numbers. Next we calculate, write down the electronic configuration of central metal atom. Cobalt atomic number is 27. Outermost electronic configuration we have 3d74s2 is there. Okay, in this case it is losing how many electrons? 3 electrons. Then cobalt 3 plus will be 3d6 is there. Okay, after losing 3 electrons. Now we write orbital notation. We have cobalt 3 plus is there. Orbital notation we have d orbital. How many? 6 electrons are there. 4s orbital is completely vacant. 4p orbital also completely vacant, and in the last we have 4d orbital also completely vacant. Okay, before filling these electrons in these orbitals we consider the effect of ligand, strong field ligand or weak field ligand. You can see in this complex ammonia is acting as a strong field ligand. Okay, cobalt, cadmium, copper and iron, in this case it will be acting as a strong field ligand. Okay, means pairing of electron will be taking place. You start filling these electrons. 6 electrons are there, 2 electron, 4 electron and 6 electrons are there. Okay, inner orbital, inner side you can see these all the electrons are arranged inner side. Okay, they are not going to the outer side. Inner orbital complex. Now you can see all the electrons are paired, so we can say it is diamagnetic by nature. Okay, option A is correct. Option A is correct. Anyway, if you go for the other complexes, pairing of electron will not be taking place. So in this case what will happen? If we do not carry out the pairing of electron, so in this case what will happen? Let's say 3d6 is there, 1 2 3 4 5 and it is 6. In each case these many unpaired electrons. Somewhere in each case definitely you will get unpaired electrons because pairing of electron is not taking place. That's why they will be showing paramagnetic by nature, but it says diamagnetic nature. Diamagnetic is only possible when strong field ligand is there, pairing of electron is taking place. That's why most suitable and correct option is what? Option A is there. If you like this video, please share and subscribe to the channel.